Hello everyone and welcome to part 3 from Forces and Motion Basics in Science Simulations. Last time we talked about motion. In today's video we will be talking and dealing with this section about friction. But before we do that, let's answer the question of the last video. At the end of our previous video, I've asked a question: why when we push a bigger mass, it takes so much time? We even measured that time with a stopwatch. It takes so much time to get it to the maximum speed, which is 40 meters per second. And also, once it started moving with that speed, takes so much time to slow it down to zero. And we compared that to when you have a smaller mass, it's very easy to get it to move at the maximum speed, and it's very easy and very quickly you can get it to stop at zero. Why? And the answer is also in Newton's second law, because force equals mass times acceleration. Or in a better way, we can say acceleration is the net force divided by the mass. So when you have a bigger mass with the same force we were applying, which was 500, divided by a bigger mass, you will get less acceleration. So when you have big mass with the same force, less acceleration, that means it will take more time to speed it up, it will take more time to slow it down. But when you divide the force by a smaller mass, you get big acceleration. And by the way, in our next video, in part 4 about this simulation, we will be all focusing on acceleration. But today, we will talk about friction. So now we will have everything as before. We have forces, sum of forces, values, masses, speed, and a stopwatch if we need it. Now, this is very similar to the motion section, except there is friction. So if you want to make this similar to the motion section, you notice that there is a skate here, so there is no friction here. In real life, there is always friction, but this simulation was only focusing on how forces are affecting the motion without bothering you with friction. In real life, you do have a friction. But if you want to make this section similar to the previous video, you can just bring the friction to zero, and then everything will be the same. And instead of having the skate, you will just have ice. And if I keep pushing this, it will just keep going forever. Why? Because there is no friction. But in real life, you always have friction. Things can't just go like this forever, right? Unless there is a force. And in real life, if you see things moving without a force, you will see them stopping at the end, because there's a friction. There's a force that resists that motion, and that's called friction. And it's always the opposite direction of the motion. This box is going to the right, so if I add friction, you will have it to the left. So the friction force is now 52 newtons, and this friction is causing this box to slow down. So it's accelerating it to the left, so that's why it's slowing down. Because there is net force, there must be change in motion, which is slowing down with the negative acceleration. Even though there is friction to the left, you could still give it a force to the right, and it must be bigger than the friction. If it's really small, you cannot overcome the friction, and it will still slow down. So you need to overcome this kinetic friction because it's moving. You need to keep pushing to overcome the friction. And then the friction again will be slowing it down. Now, if I increase the friction here, you expect this arrow to get bigger and therefore it will slow down in a faster rate. It will go to zero very easy compared to this much friction. So what's happening? You can look at the surface now. If I make a force, I get this box to move. Now I want you to keep your eyes on the surface. So as I'm adding more friction, they put some little bumps and little, let's say, rocks, and so this causes friction to be more. You see the surface is changing. It's changing. So how is your surface is affecting the friction? If the surface is very smooth, like ice, or like slippery surfaces, like wood, it has very little friction. If you make it rough, you have big friction. Now let's put the friction to maximum. As you can see, the friction is 184 newtons. That's why there is so much acceleration to the left, slowing this down. Once it stops, there is no more friction. Or we can say there is no kinetic friction. There is no friction while it's moving, but there is still static friction. The friction that preventing this box from moving. So if I push with a really small force, I can't get it to move, because the static friction will be exactly the same as the force I'm applying. I make 126, the friction will be 126. I make more, it's more, until I make enough force bigger than the static friction, which could be calculated, then you will see the same number as the kinetic friction, which is 184. So let's bring it back to zero again. So now it's 184. So maybe you think if I make 184 or more, let's say 195, I could beat the friction, I could get it to move, but you can't. Why I can't get this to move? Because the static friction is more than the kinetic friction. And it makes sense. If there is something that doesn't move and you want to get it to move, it's harder than pushing it and keep it moving while it's already moving. So the starting point is harder. So the static friction, which could be calculated if we know the coefficient of the surface, but here we will forget about that. The static friction is more than 200. It's more than 203. It's more and bigger than this, until I make enough force, maybe 230 something, then more than 240 something, then I will see the kinetic friction, 184. So friction is always there. There are two types. The static friction is while it's not moving, and the kinetic friction is happening as it's moving. So this is friction, everyone. And notice that it's gonna take more time to get this box to move to the maximum speed compared to the previous situation. But instead of jumping between the sections, I can compare using the stopwatch. So case 1, we will push the box and try to see how much time we need to reach the maximum speed, and then I will push again with maximum friction and see how much time we need to reach the maximum speed. So ready? 3, 2, 1, let's go. It took about 5 seconds, almost 5 seconds, to get this box to move at the maximum speed without friction. What if there is friction? So if there is the maximum friction, do you expect this time to be more or less? So if there is friction, the friction is in the opposite way. So instead of having the net force as 500 to the right, it will be less. It will be 500 minus the friction. So if you have less force for the same mass, you should have less acceleration. That means it should take more time. Let's see. 3, 2, 1, go. already passed 5. 8 seconds. 8 seconds, because with friction it wasn't actually 500, it was 316. That's the net force, and that's what's going to affect your acceleration. Now before we end the video, there is something else I want you to see, but let's reduce the friction. Let's bring the friction to the middle. Now notice that because this is 50 kilogram, it has this much friction, but when I add more mass for the same surface, you will have more friction. Look at this friction, 450 Newton. Even with 500 Newtons to the right, it's only like 50, because the net force is 50. So that's why it's accelerating at a very small rate. You can see the speed is speeding up, yeah, but very slowly. Why do you have so much friction here? Because when you increase the mass for the same surface, you will have bigger friction. Now, even with 500 Newton force, I can't get this to move because of the amount friction. The static friction here is so high, I cannot get this to move. If I put these down, what do you think? I can barely get it to move. But if the friction was a bit more, let's put it here, even 500 cannot get this one to move. Let's say you have a very big fridge and it's filled with stuff, so it's so heavy, the mass is so high, even if you push it, maybe you and your friend, you can't move it. But if I put the friction down and just get it to move, let's get it to move, let's get some movement, and then added more friction, oh, did you see the friction? The friction was 700. So let's try again. Let's get it to move. Let's get it to move. Add more speed so it can be clear. With this much friction, I can still move it. When it wasn't moving with this much friction, I couldn't move it, but now I can still move it. Let's see what happens when you get to the lots. Look at that! Did you see it? Let's put it to the ice. Let's move this so fast, and you will see how much friction it was producing. When the friction was lots and it's 200 kilogram, I could add more. Ready? Let's see. Look at that. Look at that friction. 1397 friction because of the big mass you have and this rough surface. I will put the game link in the description as always. Take a look at this game. It's really fun. Try different objects, different amount of friction, test using the stopwatch, and wait for me next time in the final part from forces and motion, in which we will be talking about acceleration. See you next time. Pandabood